So for this question, first of all, I'm going to choose a machine learning approach and the output metrics. And so as I get structured data and I'm asked to predict a certain variable, which is the electrical energy output from historical observations, as a supervised ML approach should be chosen. And for the output metric, I'll use mean squared error. I'll use squared error metric because it's popular and might be good to start with. And for the features and algorithm choices, I just looked at the question and what is most likely will affect the electrical power output of a combined cycle power plant is the after I asked the domain expert Wikipedia, I believe that temperature can be a primary feature. And then I think the exhaust will also play an important role in in the CCPP because it is a secondary source of power. So I will choose exhaust vacuum, which is V, be another important feature. Moreover, I think relative humidity and ambient pressures will sort of have the impact on all kinds of power plants, but they may not be so important. So I will test two combinations of features. The first one is temperature exhaust vacuum RH, and the second one is temperature exhaust vacuum and ambient pressure. So for the algorithm choices, I just think because I will use Excel as my tool, so the computational efficiency should be included, or my sheet will frozen, so I'm just kidding. And I think interpretability should come to the number one criterion because it will impact the revenue and the environment protection issues. So I think they are very important. And then comes the accuracy. So finally, I choose multiple linear regression, and I got 3 features in my model. And I also like to try the polynomial regression, but I don't have enough time, and because I've chosen 5-fold cross-validation strategy, it seems I don't get enough time, so I just try multiple linear regression. And for the test set and training set, and also the validation strategy, as I said, I'm going to use the 5-fold validation strategy. So I will use 50% of the whole observations data as my test set, and 20% of the last 85% of the observations will be the validation set, and the rest percentage of the data will be the training set. And I'll show you how I did with the separation of the data. So here is the raw data. I just label them with a number, and then I abstract 50% of the data as the test set. And then for the training set, group 1, I use about 6,506 data as the training set, and the rest 1,027 as the validation set. And so as the rest 5 groups, you can see I used 5 groups of validation and training sets, and they never overlapped between each other, so it will not the data leak will not happen. And then come back for the model comparison. Because I choose one algorithm, so I'm going to use different combinations of features. And so I got 2 groups of combination of features. So you can see TVRH and TVAP, and they were presented in my Excel as so here is a feature combination 1, and I got another combination of the features. And so I'll show how I did the analysis. For training set 1, I just used the multiple regression based in Excel regression, and I just use the 3 features. This is my group 1, and also here is the here is the observation, the output of the observations. So here is my predicted PE. Follow this model. So here I got the coefficient, or the slope of AT, the slope of V, and the slope of AP, and the intercept. Here they are, and I also see the significance I and p values, so they are really in good condition. So I combine in this model, and so as the feature combination 2, I also get the a good model. And so I just use the model to into the validation set for the model 1-1, which represent the feature combination 1, and also for model 1-2, which represent for the feature combination 2. And I just calculated the predicted value, which was the y-hat in our course, and then I just calculated the standard error of both of the 2 models. So I just compared the the error. It seems like a feature combination 2 or my model 1-2 got the better result. So that's why I just labeled model 1-2 here in my test set. I just copied all my results, all my model results here. So here is for feature combination 1. Here are the 5 results for feature combination 2, and I just compared each 2 of them, and I found out that basically the feature combination 2 or my model that ended with 2 presents better results. So because they have like smaller standard error than the first one. So I just pick out these 5 results, and I use them in my test sets, and I just calculated all the predicted results, and I just use the standard variance to compare the results, to compare the errors of the models. So finally I found out that this set of model gets the best results. So this is AT times, and the V times the slope of negative 0.228 blah 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 plus RH times this slope, and then plus the intercept. So here is my final, you can see my final model, and that's it.